Happy Bowtie Friday. I'm Austin Griffith, hanging out with the Build Guild. We're going to jump right into demos. Oh, let me make sure the security is set right. There we go. We're set so we can share. First up is Aakansha. If Aakansha wants to show your screen, show us what you've been building with Scaffold-eth. I don't even know what we're showing here. I just see you on the list and I'm ready for it. So Aakansha, take it away if you'd like.
Thank you. Yeah, this is my first show off. So I will start sharing my screen and then start.
We're glad to have first timers on. That's awesome. That means we're growing.
Yeah, 1 second.
And then next up will be Nick. All
yeah,
right,
so,
here we go.
Yeah, so what I've built is the fractionalized NFT. So I would be demonstrating how an NFT can be fractionalized, owned by the community and governed. So this is the contract that I have written, and
I can't see it yet. Can everybody else see it? Make sure. Nope. Okay, so we're waiting for it to share. I think it's probably like a network thing. It just says that you have started screen sharing, but it's like not here yet. I don't know if we're like waiting on. You might want to like maybe even stop it and try again.
Yeah, let me try it again.
Let's see. Please work. There we go. Okay, yeah, we got it. Yep, I can see it. Cool.
Okay, you can see the desktop, but can you see the code as well? Can you see it now?
Yep, you just switched to the code. We saw the 3 pins and now we see the code. Perfect.
Yeah, okay. So I'll go through the code first and then we'll go through the demo. So what I've built is the fractionalized NFT, where so demonstrating here how NFT can be fractionalized, owned by the community and governed. So so here the contract would be executed by the seller who wants to sell their NFT first. So have set some parameters like the minimum bid amount and the bid deadline. Bid amount is the minimum amount they want to sell the NFT for. And the bid deadline is till what time they want to have the bid going on. And for the created the ERC20 token called FRAC, which will represent the ownership of the NFT, which will be collectively owned by the FRAC holders. So the first function is our deposit NFT, which would be executed by the seller. And since the seller will be executing the contract, so only the seller can deposit the NFT. So have set the parameters, minimum bid amount, bid deadline, and so on. And once that all is set, the NFT would be transferred into this particular contract. So we are doing that over here. And once the NFT would be deposited, the bidding will start. So anybody who wants to bid can start doing so. For the demo purpose, I have commented the bid deadline. So we can set up the deadline till when the bid is going on. So right now I've commented that. And once the bidder sends amount of ETH, we will mint the equivalent number of tokens and the bidder would get that number of tokens. So we'll do that. And while the bidding is going on and the bid deadline is still active, and if they change the mind, they can choose to unbid. So we will, since they are getting the FRAC tokens, we'll burn the FRAC tokens that was sent to them, and they will get back the ether which they had used to bid. Now, once this has been done, and let's say the total ETH which was raised was lower than the minimum bid amount which the seller wanted, so the owner can choose to withdraw the NFT back to their own address. So this one is doing withdrawing the NFT back to their address. Now, if the total ETH is higher than the minimum bid amount, so that means the owner will renounce the ownership of this contract, and the ETH which was collected by this contract, the person can withdraw it. So now the NFT the ETH has been claimed back by the seller. Now at this point, the NFT is now collectively owned by all the FRAC holders, because everybody who had bid has the ownership of FRAC tokens, and the NFT is fractionalized. So now the next thing that I have done here is basically how the community of Frac tokens can use this contract to execute to call some proposal and using governance. So here we are using some parameters like to data what data they want through proposal, and what is the deadline, like what is the deadline they want the proposal to get voted on. So then we are using these parameters to create the hash, and once the proposal has been created, by default the person who proposed would vote yes to that. So that the proposal gets created, it gets voted on first, and now it is open for vote. So again, the same parameters will get passed, the hash would be created, and the person can choose to vote on it. Yeah. Now the proposal has been created, voted. Now if the majority of the majority of the tokens have voted, the proposal will get executed. So here we are executing the proposal by sending the data whatever we have passed, and that's it. So we can also use this proposal to, let's say, sell the NFT to some marketplace. So if we are selling it to some marketplace, we'll put that in the data. And let's say after we have sold, we get back some ether in our contract. So at that point, maybe all the bidders would want to claim their ETH back, and that would mean they would have to burn the tokens. So this is what reclaim ether function is doing. So once they have sold the NFT, we have ether in the contract, all the bidders can burn the NFT and reclaim the ether. So this is the contract, and let's go to the demo.
That's awesome. And just to run through that really quickly, basically you're locking up an NFT in a contract and you're getting an ERC20 back from that. But there's also this proposal system of putting the NFT up for sale and then splitting the funds based on some ERC20 that you're dividing. Is that right? Kind of from a high level?
Yeah,
Cool.
exactly. And
Awesome.
You can create any kind of proposals you want, not only just selling the NFT, any kind of proposal.
Okay. Cool. Yeah. Cool. Thank you. Okay, here we go. Big demo time. I see 3 frames.
Yeah, so I've created the 3 frames. The first one is the seller, the person who would be selling, who wants to sell the NFT and would want to put in the contract. The remaining 2 are the bidders who would want to bid. So I'm taking the token ID 0. I want to sell for the minimum of 0.1 and deadline. I'll just put the deadline here. Yeah. So first the NFT would be minted, for which the contract has been written. Then it would be approved, and the NFT would get deposited in this contract. Now we can see the contract balance is 0. Now anybody would want to bid on it. So this is the bidder. They want to bid 0.5. And similarly, the third bidder also will bid 0.05. And we can see that once they have bid, they will get some frag balance. And since 2 of the bidders have done, so we have total supply of 0.1. Now let's say the deadline has passed and the minimum bid amount is also done. So now the seller can come and claim the sold ETH. And at this point, once they do that, they will renounce the ownership. So, okay. Yeah, it's already, they claimed it back. So now we have balance 0. Now the next that we will see is how we can create proposals. So right now I'm just doing the proposal of selling the NFT. So I want to sell the NFT. So I'll take this NFT address. I will create some call data. So and the deadline. So I will click on propose. So this is the proposal that I have created. And by default, I have already voted on that. Now, second person can choose to can choose to vote on it. So they will go to this, they will again put all the details. And they will vote on it. So now, since only 2 of them are the holders, the majority of the token holders have voted, so we can execute this proposal. So this proposal was basically selling the NFT to some NFT marketplace. So we would expect some Ether in our contract, but for the demo, I'll just send some Ether to our contract. So we have 0.5. Now, the bidders who were the holders of the Frac tokens, they would want to burn their Frac token and reclaim back the ETH, because the NFT of this contract has already been sold. So we can see right now the Frac balance is 0.05 and total is 0.1. So the ETH that they can claim would be proportionate to the Frac balance that they have. So once I click claim, yeah, so we see the balance is 0.05. Now, if I check the balance of this, Frac balance is 0, supply has become 0.5. Similarly, I will claim the balance is 0.05 here, Frac is 0.05. I will claim, and the contract balance becomes 0. And if we check the balance of Frac balance now, it will be 0 and this will be 0. So basically, yeah, this is the end of the demo. This is how we just saw that how NFT was just fractionalized and proposal was created and people voted. And yeah.
Fantastic Scaffold-eth demo. This is awesome. It's this, I always say this on everything, but a good Scaffold-eth demo is kind of ugly, but this is even more. It's not just kind of ugly, it's complicated, right? There's a lot of UI here and there's a lot going on and there's a lot of different actors doing different things. Fantastic Scaffold-eth demo. You should share the repo for this, but you should also share your BuidlGuidl profile. I don't think I've seen you around, and it's great to have new folks on. And yeah, share that stuff with us so we can reach out and keep this going. Aakansha, that was like a fantastic Scaffold-eth demo, though. Keep building and keep working on this kind of stuff. Awesome stuff.
Thank you.
Okay, who's up next? Let's see. Who is on the list? I think Nick is diving into some arbitrage stuff, right? We're all kind of learning arbitrage together in this one channel, and we've kind of done a couple explorations, but love to see what you put together. Nick, go ahead and take it away.
Let me know if you can see my screen.
Yep, we got it.
All right, so you see the tokens on Uniswap?
Yep, it looks like Feth. I don't know what Feth and Feth die are, but
this is my fake ETH and fake
got
DAI.
it. Got it.
Right, so the goal here was to create an arbitrage challenge so we can teach the BuidlGuidl and other people who want to learn. And I want to learn how to swap, like if there's like a potential like price difference in 2 pools, like on V2 and V3 Uniswap, if ETH and DAI is a different exchange rate, we can try to pull out the difference of that. So I just wanted to be able to like build a whole like basic working model on Goerli testnet, and then actually do the flash loans, try to like capture the difference, and then see if I could actually get it to come to my account with that profit. So I created 2 fake tokens, fake ETH, fake DAI, created a liquidity pool on Uni version 3 and Uniswap version 2. And I set the reserve ratios differently so that there would be like an arbitrage difference. So this is my pool here. And then just to show you, like the current exchange rates is 1 fake DAI is 1.7 fake ETH on V3. So then if I go over to my build, this is super ugly, but it's just—
That's how it should be.
Perfect. I just want a front end so people can see what's going on. So in the middle here, this is showing the exchange rate difference. So on V3, it's 1 DAI is 1.17, and then on V2, 1 DAI is 7.87. So there's a huge difference. And then what this is going to do is show is like if you borrow 1 DAI and you convert it, then bring it over here, how much would the price difference be and how much profit you would make, all right? So the problem is on these, the way automated market maker system works, you don't really know, there's not just an exact exchange rates. It depends on how much you're putting in is how much you'll get out. So it kind of varies by how much you're trading or exchanging. So that's why I listed here, like the examples of like, if you were just borrowing 1 DAI or 2 or 3 or 4 to 9, and then it shows you how it would change the exchange rate. So then what the code does is it monitors like what is going to be the most profitable, right? So then it shows here like 4.36 would be the most profitable. And then at the very top here, you'll see this optimal amount to borrow would be 9 FDAI. So it already calculates it all for you. So all you have to do is click the execute arbitrage button. And let's see. So that's going to take a second. So when I do,
it was with a burner wallet. We didn't even see a pop-up there. Did MetaMask pop up, or are you running this on a burner wallet?
No,
that's
this is live. This is live on Goerli with MetaMask, right? So it's running.
Oh, with MetaMask. Okay. Yeah. We didn't see your MetaMask, I don't think.
Okay,
that's cool. Just letting you know. Yeah. Perfect, okay. Perfect. But you clicked OK on a transaction, basically. Okay, cool. So
I have to shield this. I love this Excalibur. So anytime I do builds now, I just want to go ahead and include this just to show, I build this for myself, but then also to show people later on what's going on. And it ends up getting a little complicated, but if anybody is actually interested in trying to figure out what's going on, they can always come reference this. But basically, Alice is initiating the arbitrage. She borrows the DAI. So it's basically a flash loan. You're going to borrow that 9 DAI, send it to your contract, go exchange it on Uni V3, and then it all comes back and you have to pay it off in the end. And then the profit gets sent to whoever initiated the arb. So let's go see if, well, one thing about this Excalibur is that if anybody's interested, like you can actually use it yourself. So let's say you thought like, no, like this should come over here, or this should happen first. You would move it around. And then there's an option here. You just click this button and then you can save the image. And then you could share it with other people to kind of like collaborate, but it's like super easy to use. All right, so we did that arbitrage. Refresh this. So then this shows all the transactions that it went through. It borrows the 9 DAI, exchanges it, and then the very last transaction, it sends out the profit to your wallet. And then there's another option. This is just to show that the calculations are done on chain. If you want to use ABI Ninja, right, you can just go ahead and paste in that contract address. And this is just showing the one function to do the arb. So if you already know how much you want to arb, you would just come in here. Let's say you're just going to do 1 DAI and you click send. This is what I really love this feature on the ABI Ninja. So I can share this link with other people directly and they can just come in here and do it. So anyway,
shout out to Carlos.
Yeah, loving it. And it's kind of cool. Like I like this feature on the side here where you can show the different addresses. So then I made everything public so people could see like what is the pool address on V2 and V3 and the different routers that I'm using. So I think
I'm assuming that most arbitrage is done with scripting. You usually probably won't have a big button you go hit, but this is awesome and it's a good way to explain it to people. But yeah, I'm guessing it's like a fraction of time. Like you have a couple of seconds to execute this thing before you get outrun by other people, and it almost has to be like an automated script. But when we're talking about teaching folks, I love this. Like, yeah, I've even been thinking about like a script that would deploy a DEX or multiple DEXs to their local host. So they fire up localhost, and then we have a website that uploads 2 different DEXs, puts tokens in at different rates, and then their challenge is to arb those just locally with like it could be a button, could be any kind of a front end. So this is great stuff.
That was a bit beyond my skill level, so that's why I went with Goerli for now. But it is nice that there are different exchanges on there live. So I can also do like multi-hops, and then Flashbots is also on Goerli. So if we want to integrate flashbots, which is really what you would actually need to do to get this actually being profitable, all of that's there. And right now you can go in and mint more tokens and add to the liquidity pool to increase the arbitrage levels. There's a lot you can do. But now, so what's next for me here to make this as a challenge for the guild? Like now that I have a working model, like break it down into pieces.
Can you write a script that would put all this stuff out on Gourly in like a one button kind of way? So the orchestration, I think, is probably the most important part here. If someone else would like to try to build an app that does arbitrage, could you run a script that puts sets up the two pools in V2 and V3 and sets up the tokens and all that stuff, and then says, here's the address for these if you'd like to go attack it yourself?
I mean, this is already in. This is a Scaffold-eth build, and it's forkable right now. So you would deploy your own contract, but it is hard coded at the moment. But
that's probably fine.
Create two like my own versions of Uniswap, or just use the ones that are already on Gourly?
Yeah, just use Gourly. I think you would just use Gourly, and you would just. I think you've already done it. Basically, if someone was looking to get into arbitrage, this is probably one of the first stops. Well, I'll drop them into that Telegram channel. We'll send them. Maybe we could even pin this in that arbitrage channel as like a good kicking off point. I think for you, if you were exploring this farther, I think it's like time to start looking at like little mainnet scripts and tinkering around with like, can we pull off an arbitrage? Even if we lose a little bit of money, it would be fun to figure out like, what are the other intricate details here of being competitive? And I bet there's a rabbit hole there, but just like having those discoveries would be fun to share with the Build Guild.
Yeah, it's endless optimizations, but it's kind of interesting if we do have it as a challenge with the guild, and it's kind of like the multi-sig.lol. Every person comes in and they iterate and they make it better and better. So imagine this, it keeps improving. So it'd be pretty exciting.
Yep. Awesome build, Nick. Keep going, man. Keep learning. It's like today I learned too. Like I learn all this stuff a lot from you guys because I'm not digging into the rabbit hole of arbitrage myself. So I love seeing this stuff just for my own education. Okay, I think Damu is up next. Our homie Damu. Are you out there? I see him.
Hi, how are you?
Good to see you. Doing well. Happy BTF.
Yeah. I have two related build to show today.
We've got the dice random up.
Yeah. The first one is this dice random game that the main issue is that used a future block difficulty that is now in the proof of stake is a random source to get the number from the dice, and this is how it works. Is first you get a number from 0 to 15, and when this is saved in the contract, it's set that the dice will roll some block after you bet. So you have to wait to roll the dice when this block arrive. And in the are you seeing my the README now in the stream?
Yep. We see you switch over to the README.
Yes.
Yep.
Okay. And in the front end, what is done is get the block header from this block number and call the roll the dice method in the contract, sending the header LP encoded, so the contract can check that this is the right block header. And if I go to the contract, I have. Do you see the code now?
Yep.
And the contract here, this is another contract, but it's the same. I get the block number from the p block header that the front end send, check if this is the right block. This is the block from the bed, and the future block that I want to await. And then is the block hash, and then the contract calculate the block hash from this block header and the block hash that is available in the with Solidity with block hash block number. And if this is okay, this means that the block header was not modified, and this are right block header. So if this is okay, this can use this header, the mixHash. This is where the random value is in the header, in mixHash. This is the 13 index in the header, in the block header that the block front end sent. And so this is used to calculate some random stuff. In this game is the number get from the dice. So here, if I roll the dice, I will get the number from this random source. And the nice issue is that this is unpredictable. So nobody can predict how what number you will get. And well, you already bet and you spend the money before this block was minted. So this is a really random number generator direct from the blockchain, and I think that can be hacked.
I think that's the thing to lean into here is there's lots of different ways to get random, but this one's the really good way. Like this is using future block difficulty and having them submit the header and hash it out is complicated and complex. And when you look at like, why can't we just use current block header? That works for a lot of things, right? But this works for like, if you wanted to have like $1 million lottery on Ethereum, you couldn't use block header. You probably couldn't even, you could use future block hash maybe, but using future block difficulty, the way the pre-Randau stuff is working, like that is the way to go. And so I don't know. And this is a technical challenge, getting that header all together and getting it to hash correctly. There's a lot of work that goes into making this work right. So yeah, you're saying this is really good randomness on chain, but by saying that, like, it doesn't even give it credit how much goes into making this random really random, right? And we have services like Chainlink that provide like oracles, but you have to pay for those. So that, like, this method that you've created here came from like LightClan. Like a couple people like posted it on Twitter of like these were gigabrains coming up with how you would do this, and you implemented it in like 2 days. So great build, and I will be forking this for a game in the future for sure. Definitely like make sure it's available for us to fork. I think you said you had 2 builds too, right?
Yeah,
okay, cool.
I will send the event for this.
Please do.
The dice game that is the front end and the content stuff to
and like Nick said, when are we playing more next?
And the second one is this Mandala merge that is an NFT, a random NFT that use the same logic from the dice number to get a really random mandala. This mandala are generated randomly for using the same logic from the dice. So these have 5 different color and 5 different radio and 5 different X and Y location, and these all stuff are generated from the same random source. Here is the sorry.
These look like they're going to kill my browser. Like the snakes on chain where they go all slow because my browser can't do hardware acceleration or whatever.
Yeah, it's some hard to the CPU.
So these are being rendered on chain though, right? You're drawing like a whole bunch of circles and it's all done in
Yes.
Solidity.
Yeah, first I get this sheen using the same technique that from the dice, and then it's really simple. It's I have a form for each circle that have I use the X, the Y, the radio, the R, and the color using some position of these genes. And then I add the animation, changing the radio, some a little bigger than the radio that it's get from the gene. And then I rotate this circle to make the mandala. And well, it's look really nice.
It does look awesome. It reminds me of like, I think what they were called spiral graphs or something. As a kid, I used to like with a pen, they were the thing that would go around. Looks so cool.
Yeah.
And you animated them too, which is another thing.
Yeah,
so it's like
yeah,
drawing it and then redrawing it and redrawing it. Is that what's happening? How does the animation work in the CSS in the smart contract?
This are you looking at the code? No.
Right now we see the mandala.
I think that you are seeing the code. I will show again the code.
We saw some of the code though. We saw the code where we were seeing the CX and the CY and everything. Like I saw that part.
Okay.
I just didn't see the animation piece of it. I might have missed it.
Can you see the code now?
It's loading. Oh no. Come on. No, for me it says it's not up. It's okay. No big deal. It's not a big deal.
Okay, it's a animate tag from SVG.
Okay, it's the animate
that
tag.
That you can set an attribute and some value for this attribute that is changed in some time interval.
So every one of the circles basically are wrapped in an animate, and the animate kind of slowly kind of moves them back and forth. Is that right? And then like they all kind of move together?
Yes.
Cool.
Yes, because I really have 5 circles that the circle are rotated to make the mandala. I will send the code later, and you can see it's look complex, but it's simple.
Yeah, it would take me a while to write it, I bet. Yeah, drop it into the chat over here so we can share it with folks that watch the video too. And I think Alex, you are up next. I think maybe Alex, great build, Damu, of course, mini builds. This is almost like your 100th Scaffold-eth build. You're becoming a veteran, and you're becoming our go-to guy for randomness. So pretty soon we're going to be, the Build Guild is going to be like a Web3 dev shop, and Damu is going to be running it, and we're all going to be answering to him. Another great build. I look forward to what we do next with this technology, like that header submission stuff and the pre-Ram DAO is TDD. That something really neat is going to happen from that, and it's the best possible randomness you can get on chain without paying for it. So that's so cool. So let's keep pulling that thread and see what we can do next. Okay, I think Blind Nabler's up next. I think I've already seen this a little bit. It's kind of a ETH build, kind of new fork of ETH build, or new rebuild of ETH build. But take it away, Alex.
Sounds good. Yeah, so also I was gonna say one thing to Damu. have you looked into any of the other metadata standards that like OpenSea and a lot of these other NFT platforms support? Because I actually found you could do really interesting stuff by like doing like the normal base64 URI encoding. But if instead of making it an SVG, you can actually just encode an entire HTML page in there, which allows you to like write full-blown JavaScript within the iframe tag that they support. And so I think like it's an interesting sort of rabbit hole you can do to dive down weird on-chain stuff. You write in like JavaScript and making your things just like one weird static site. But anywho,
Nice.
I think they put like P5.js on Ethereum last night too. I feel like I saw that on Twitter somewhere. They're starting to put like JS rendering libraries in, so you can pull those off chain and then add some. I don't know. It's really cool stuff, but IDK if we should be putting all that stuff on chain. But also, I think it's awesome to make SVGs on chain. So the
more
answer is
state
probably yes.
load,
Yes,
more
we
state
should.
load.
Yes, exactly. It's why I have to have a giant hard drive to run this thing.
to fit all these random 3D spinning donuts on chain.
Garbage. Yes,
it's important.
Love it. Love it. All right, you're up, Alex. I'm out of here.
Anywho, yeah. So I have been working on this for a little bit, tweaking around with different frameworks and trying to just, I guess, like figure out the best way to implement this. So one of the things that really got me onboarded into Web3 was actually Austin's ETH build, which if nobody has seen it, I would highly recommend checking it out because it's a really rad piece of software. And basically what it is it's a node-based editor that makes it super easy to interact with the blockchain in a visual way and really kind of teach and showcase these concepts to beginners and new people in a way that isn't as scary as working with the random JavaScript framework or a Python framework. It's like a really, really great starting point. But one of the problems is nowadays it's unmaintained and a lot of the things don't work because they're using Web3.js, and nowadays everyone uses ethers if you're sane. And so I was like, oh man, this is kind of a problem because like I really love ETH build and I want to recommend it to people. And if anyone's curious, I'm like, oh dude, go to ETH build, blah, blah, blah. But the like node framework that they were using to build out the current like platform and interface is unmaintained, and it just kind of is all written in vanilla JavaScript, so it's not super maintainable. And so I was like, well, how can we fix this? Like, how can we make a better forkable, better experimentable, and better maintainable version of ETH build? And I was like, oh, we have TypeScript. That's a great thing to use. And so I started building a new version of ETH build with maintainability in mind and like future maintainability in mind, and just kind of like simplistic design standards in place, I suppose. And so I built out this working prototype of some of the ETH build-esque things using ethers.js under the hood, as well as recoil for state management, and all written in TypeScript, and using very, very minimal frameworks other than just the rendering of the node stuff. So that way it's all there and functioning, I guess, as time moves forward. We'll see. Entropy always increases and things just always get more disordered. But I'll go ahead and stop talking. We can share my screen and I can showcase some of the stuff. It's still in a pretty rough, ugly state, but I think it'll get the message across. And Austin saw a little bit last week, but basically here's the thing right now. We have some things set up, and kind of the general like design pattern I chose was, I was like, we should have inputs which connect and send their data into pipes, which mutate that data and then can send it into display nodes to showcase that data, or they can pipe that data, kind of like when you're working in like a Linux command line or a Unix command line, I suppose. You can pipe that data into other pipes to do weird, cool things with it. And so here's just like some simple playground stuff I use to showcase this. So we can start off with like some like numeric stuff, I suppose. So here we can get like the modulo of 107, which will return 2 over here on this display node. We can also pipe that result into an AND node, which will, only display whether or not both A and B are valid. And we can see that over here in the Boolean display node. We have things such as like hash functions. You can say like, hey, y'all, happy Bowtie Friday. And here is the hash of, hey, y'all, happy Bowtie Friday. And it showcases these concepts in a very sensible and easy way for beginners to understand. And then also, like, obviously, doing math and stuff like that's cool and all, but what we really care about is actually interacting with the blockchain in this case and teaching people. So we can teach people, what is a provider? So like a provider instantiates a version of the Ethereum network, and we need a JSON RPC endpoint and a chain ID in order to get our balance, which then we plug an address in, and then we can display this address and, formatted big numbers. And so like, this is just Vitalik's address, but it also works with any other address, I suppose, if anyone wants to plug those things in or play around with it. But we have, I have a bunch of different really ugly pipes. It's not formatted all pretty yet, but all these things are functional and can work. And it's been a lot of fun building, and I've been enjoying it. So I hope that, as I put in a little bit more work and we close it up, I would be super happy if anyone else wants to hop on board and start building out random nodes and building out random projects and teaching people about the blockchain in a visual way, because command lines can be scary for new people like I once was. So yeah, it's a lot of fun.
Awesome. Yeah, I think that was one thing that I was always looking for with ETH Build, was like a community to jump in and build the components, because the components are super simple. It's like this little, like, very modularized thing has some inputs and some outputs, and you as the programmer don't need to know about the rest of the system. You just need to know how to manipulate those inputs and output something. So it's easy to build lots more components. So as you get to that point, make sure you share the code off with other people and
showcase any of the TypeScript, but oh well.
Yeah. Cool, man. Good build. Yeah, share the code with us too, and keep going on it. It'll take a while before it's. Oh, go ahead.
I can actually just like drop my GitHub link in the chat, and you guys can. I'll take a look at it.
That's a good way to go.
Here is ETH rebuild.
Okay, and I think we got Chris Cag is going to show off some generative art next. Nice, good share there. Yeah, keep going. You've got a ways to go before it looks like ETH Build, but I'd love to see it get there. I'd love to see you keep going on it. When you're ready for more developers or you're ready for a designer, let me know and we can help throw in some resources there. But yeah, keep going, keep building. It's a good prototype.
Yeah, totally. And yeah, if you guys have any questions or recommendations, please let me know. I'm your paintbrush to build this thing out, so please use me.
Woo. Okay, Chris Cag, are you out there? You should be able to share your screen. Go ahead.
Yeah, hey, I'm here. I'm gonna share my screen. Okay, so here you go. So this is what I'm working on right now. It's an NFT drop. Like this is the build, sort of like refining over time. But I think I'll use another template of Scaffold-eth. But yeah, basically. Just another collection of NFT that is using like P5 jazz. But like, so I was kind of stuck on this for like a few days, because the only solution to like render the JavaScript scripts was to like host it on a server, which make the artwork being like sort of centralized. They're using sort of their own API. So that everyone is gonna call, like if they're on OpenSea, they're gonna like it's gonna call the Outblocks API. So I didn't want to do that. I was looking for something that would be more decentralized. So I kept on searching and searching, but I couldn't find anything really interesting, because like the goal here was to recreate this on anyone's browser. Like needing a server. So like the same animation that you can see here. So I ended up like finding this. It's called Frame, and they deployed like their own contracts, and they show like how you can like sort of like hold like reusable browser code already on chain, such as 3JS or P5JS. So like basically the contracts like they save like the necessary scripts like every time. So like when you're gonna call like the contract, if you want to see the artwork itself, you'll be able to like do it in a decentralized way. Yeah, and permissionless as well. So like one example, because I haven't succeeded doing so, but I didn't have time to work on it, but there's a good example here. You can see this is called math castles. It uses sort of the same technique, yeah, same method in the contract. Everything you see here, it's P5.js scripts that is being generated. Like, yeah, a good way to see is like you cannot like, for example, like see it in another tab, because like if you go on like on other NFT artwork, if it's an image, that means you can. Okay, I'm gonna take this one. This one as well. Yeah, that means yeah, you can see it's calling. Yeah, it's calling a link, and that's where you can like see it in your browser. You can even download it, save it, and everything. But like these ones are only yeah, this one. These ones are only generated every time you're gonna call it. That means like the contract itself. And this is pretty cool because you can you can do a bunch of stuff with it. You can make interactive art. That means like someone can just like mint a canvas and like paint on it. Yeah, it has endless possibilities, and that's what I'm like working on. And maybe like create a build so that anyone can learn and use it for their own project. Yeah,
Awesome build, dude. I love this stuff. I like going back to putting things on chain. It's really fun. It's like a flex when you can generate the entire image from a smart contract without any other libraries, or if you have the rendering library and you put it on chain. And we already made the state bloat joke earlier too. So it's like, if you're willing to pay to put the thing on chain and other people are maybe even buying those things, that's awesome. So yeah, it's such a cool flex.
Yeah, but like this made this contract made it possible to like host it at a low cost. So you don't have to pay a lot of gas to put everything on chain. I think you just like store a part of it on chain, and then when you call it, it calls the rest. I haven't understood quite the contracts themselves, but like I'm gonna explore it further, and I'll show it in another BTF if possible.
Awesome, dude. Yeah, keep exploring this generative art stuff. I feel like it's definitely like a niche that you are exploring and doing well with. So keep it going. Any last builders? BTF? Last things? Etta, you want to show off the Web 2, the Web 3 stuff real quick? And maybe we can close with that. That'd be kind of cool just to talk about what we've been thinking about with that stuff. Oh, you're muted.
Right. Yeah, for sure. I can show that and we can just like go through that for a moment. Not going to take a lot of time. But let me share my screen and we can just talk about that. So I think we've mentioned it a few times on the Bowtie Fridays actually, but we've been working on a curriculum for developers to get started. And it's so it starts by becoming a power user on Ethereum. And it's a set of videos. It's completely open source, free, anyone for use. And we've been working together with Austin and Carlos for a pretty long time, actually. I think we started shooting the videos in May or even April. But it's over 15 hours of videos where you have like 3 weeks of videos, and then 4th week is like more kind of the person watching the video should go through the tutorial. But we have this awesome banner as well. And you can go over here to the playlist to kind of see what we have over here. And yeah, 3 weeks of videos. Of course, everyone can do it on their own time. But the first week is more becoming like a power user. It's not really about coding at all. It's just, what's MetaMask, how to get that set up. I think that's like especially important when we want like more Web2 people to come in. And then we go through scripting. Carlos shows us a lot about different scripting stuff. I learned a lot from Carlos and Austin while shooting these. And then last of all, like building more, we run through speedrun Ethereum, but not like showing the code, but just like an intro to all the different tasks you have over there. And then last of all, kind of graduate the people to build their own projects. But yeah, this is the curriculum. You can see like we have different notes as well for the different sections. Feel free to like watch any video if you want to, or share with, you know, whoever wants to become a Web 2 to Web 3 developer. Very developer focused, very open curriculum, free to use, free to fork, free to star. But yeah, that's a short intro about what we've been working on.
Awesome stuff. And it's actually very slow. Like we purposefully just got on and hit record and went through things very slowly. Like this is your mnemonic. There are times when we purposefully like put in a transaction where we know the gas is too low and we get hung up in the mempool, and then we have to go through like speeding it up. But maybe MetaMask is kind of being a punk and we have to like reset things and then speed it up. We go through all the things that a normal user is going to run into, and we go through nice and slowly so they can kind of like really digest the content. And that second week, shout out to Carlos, was all like scripting and providers and setting up Node. And my like, I always use Scaffold-eth for everything. And I had my own blind spots because of this. And Carlos went through and kind of really like addressed those blind spots. And now I feel like I'm a pretty good scripter thanks to this second week. So shout out to Carlos and Etta for all of the help with this tutorial. And hopefully it will be a public good for the ecosystem. Awesome stuff. Happy Bowtie Friday. Another one in the books. Boo-boo-boo-boo, boo-boo-boo-boo. Thanks, everybody. Thanks for being here. Hearts, hearts, hearts. Happy Friday.
Thanks,
Thank you.
everyone.